Okay, fine. Uh, so I was telling about static routing. So like in manual routing, we have two types. I'll just show you guys. So coming to routing, coming to routing, we have two types of routing. So one is manual routing, and we have dynamic routing. Dynamic routing. So in manual routing, we have two types. So coming to manual routing, we have finished static routing, and default routing. Coming to dynamic routing, we have IGP and EGP. So we'll be discussing what is IGP, EGP, all these things. In IGP, we have RIP, we have EIGRP, we have OSPF. Coming to EGP, we have BGP. Okay. So guys, who missed manual routing, static routing, you guys can refer to the video which I have uploaded. So we are done with static routing and default routing in the previous class. So today we'll be moving to dynamic routing. In dynamic routing, we have IGP. For IGP is nothing but interior gateway protocol. So we'll be studying about RIP for today's class, today's session. So I will rewind back whatever we did previously. I'll just so So you know what is routing is nothing but forwarding packets from one network to another network. And what is routing, routing table, all these things. I have made a video. You can just check. I have did for all these things static routing, and I have done lab as well for this thing. And default also you can. I have shared the notes. You guys can check with default routing also. And coming to dynamic routing, so advantages of dynamic routing is like there is no need to know the destination network. But coming to static routing, we need to know the unknown destination networks and its subnet mask and its next hop IP address. But coming to dynamic routing, no need of giving its destination networks. And need to advertise the directly connected networks. We are going to advertise the in dynamic routing, which is directly connected networks. Like we have R1, R1 is connected to R2. So we are going to configure directly connected networks. But coming to static routing, we used to configure the unknown networks. Okay. So next, neighbor routers exchange routing information and build the routing tables automatically. These neighbor routers, they are going to exchange all the routing informations and routing information and build the routing table automatically when it is coming to the dynamic routing, and updates the topology. In dynamic routing, it's going to update the topology changes dynamically means everything is done automatically, and administrative work is reduced. Why? Because everything will be done by the dynamic routing. But coming to static routing or manual routing, administrative work is we have much work because we have to configure each and everything coming to its IP address, subnet mask, default gateways, everything we are doing manually. But your administrative work is reduced. And this dynamic routing we are used for large organizations. We have discussed earlier only about this. It's used for larger organizations. And this is easier than static. This dynamic routing is easier compared to static because everything is done dynamically. So we have types of dynamic routing protocols. Distance vector protocol is also called RIP. RIP is routing information protocol. So today we'll be discussing about RIP. RIP is routing information protocol. Okay, this RIP is like works with Bellman Ford algorithm and its periodic updates, and full routing tables are exchanged. This is a classful routing protocol, and examples are RIP version 1, and we have version 2 also. So we'll be discussing about distance vector, that is a RIP. So we have something like classful routing and classless routing. Classful routing protocol don't carry the subnet mask information along with updates. So classful don't have any kind of subnet mask like class A, class B we have discussed, right? Subnet mask. For class A, subnet mask is 255.0.0.0, but class B is 255.255.0.0. But coming to class C, it is 255.255.255.0. So it doesn't have any kind of subnet mask when it's coming to classful. But classless routing protocol is going to carry the subnet mask information along with updates. Classless. So these things I discussed in last class only. I'm just giving the like revision like whatever I did in the last class. Okay, so today we'll be discussing about RIP. So as I told, in dynamic routing we have three types. That is IGP. IGP has three types. One is RIP, AGRP, OSPF. We are discussing about RIP, routing information protocol, right? So autonomous systems. What is autonomous systems? The collection of devices under an organizations, like that is called an autonomous system. Like example like ISP. ISP is like internet service provider. These provide the internet to the businessman or to home use purpose or anything for business purpose. All these things, these ISPs are providing the internet. So like Airtel, Jio, Idea, BSNL, all these are the ISP providers, right? So autonomous system is collection of devices under on organizations. That is nothing but autonomous system. So we have IGP and EGP protocols I was discussing. So IGP comes under, RIP comes under IGP. So IGP protocols are used to enable communication inside an organizations. So these IGP protocols will enable the communication inside, only within the organizations. That is IGP. But coming to EGP, EGP protocols are used to enable communication between the autonomous system. So this is between the autonomous systems, but this IGP will be inside, interior, within the organization. So next, coming to RIP, RIP is a routing information protocol, right? And it's a distance vector routing protocol. We call RIP as a distance vector routing protocol. And the metric in RIP is called hop count. So we have router 1, router 2 and router 3, router 4. So this is R1, R1, this is R2, this is R3, this is R4. So now R4 wanna reach R2. So it is having one hop and two hop. So one and two. So your see the it is a distance vector routing protocol, and the metric in RIP is called hop counts. So whatever the metrics we are calculating, we call in the RIP as hop count. Okay. So next, the algorithm in RIP. Okay. Next, the algorithm in RIP to find the best path is called Bellman-Ford algorithm. So in RIP, we are using Bellman-Ford algorithm. Okay. Next, the Bellman-Ford algorithm counts the hops of updates and find the path which have the least hop. Hop is the hop count is a metric, like how like I just showed you the example. So it is having one hop, two hops. Now R4 want to reach to R3. It is having one hop, two hops, and three hops. So this is the metric we call the metric in RIP we call as hop counts. Okay, and the bell this algorithm which is used in to find the best path is called as Bellman-Ford algorithm. Okay. Next, the Bellman-Ford algorithm counts the hops of updates and find the path which have the least hop. This Bellman-Ford is going to count the hops and of the updates, and it's going to find the best path and which have the least hop. Least hop means which is the nearest way. So it is going to find the least hop. And the path which have the least hop will become the best path, the path which is having the least hop count. Like example, you think I'm having four routers. So this will be R1, this will be R2, R4, R5, R6, this is R7, this is R8. Now R8 wanna reach R6. So one way is you can go from one hop and two hop. Okay, this will be one hop and two hop. So R1, so R1, sorry R8 wanna reach R router 6. So it is having two hops in this way if it is going. If it is wanna come in this way, in other way, so it will have one hop, two hop, three hop, four hop, five hop, six hop, seven hop. So it is having one, two, three, four, five, and six, and seven. It will be the seven hops. But it can reach in this way also. Third way will be one, two, three, and four. Four hops. So best way, so this Bellman-Ford algorithm is gonna look at the lowest hop count. So lowest is 1, 2. So this way this is gonna consider lesser hop count is 1 and 2. So that will be the best path. So coming here, the path which have the least hop will become the best path, as I told. And RIP is the first dynamic routing protocol. So dynamic routing, as I told, in dynamic routing we have IGP and EGP. In IGP we have three types: RIP, AGRP, and OSPF. So this RIP is the first dynamic routing protocol. Okay, and it's a open source routing protocol. Open source means which is available to everyone. There is no cost. So it is a open source routing protocol. And RIP sends routing updates in every 30 seconds. So RIP is gonna send routing updates in every 30 seconds if any changes is happening or not happening, but it keeps sending periodic updates in every 30 seconds. So example, like, see, like this is the one configuration we have taken, and in a RIP, as I told, it keeps updating every 30 seconds. So like something has changes happen, like link change to up or down, some updates is happening, it keeps updating in every 30 seconds. If changes happens or no, it doesn't matter, but RIP is a periodic updating, it keeps updating for every 30 seconds. Okay, so RIP sends routing updates in every 30 seconds, and RIP will send its entire routing table to its neighbor routers in every 30 seconds, as I told. And RIP is a periodic updating protocol. It keeps updating periodic basis. Like every periodic means every 30 seconds, because it updates periodically. And RIP uses UDP port number, that is 520. UDP is, I hope you guys remember what is UDP. Anybody can tell me what is UDP?
User datagram
Anybody can?
protocol.
Huh?
User datagram protocol.
I'm not able to hear. Can you be louder? There's some network issue here.
User datagram protocol.
What is that? What is the difference for TCP and UDP?
Connectionless protocol.
Which is
Transfer.
connection? Yeah, TCP. UDP is connectionless, right? Okay. So RIP is gonna use port number, that is 520, and RIP supports maximum 15 device inside an autonomous systems. RIP supports only 15 devices. This in RIP. And RIP supports IP and IPX. So it supports Internet Protocol and Internet Packet Exchange. And RIP AD value is nothing but administrative distance of RIP routes is AD value is 120. Coming to AD, it's very important AD values. And in dynamic routing protocols, load balancing is enabled by default. In dynamic routing protocols, load balancers is enabled by default. Load balancers is nothing but it is going to distribute the traffic equally. So this will be enabled by default. And coming to types, we have types of RIP. So we have IPv4 version and we have IPv6 version also. So anybody know or can tell me what is the difference between IPv4 and IPv6?
IPv4 is a 32-bit address and IPv6 is a 48. mm, It can hold 128,
Yeah,
2 power 32 and 2 power 128 is
exactly.
the num. Yes, and we are having a transaction from IPv4 to IPv6 in order to accommodate more number of hosts.
Okay. Yeah.
Yes.
So we have types of RIP, that is IPv4 and IPv6. In IPv4 we have RIP version 1 and RIP version 2 in v4. In IPv6 we have RIP next generation. Okay, so what is this RIP version 1 and what is this RIP version 2? So coming to RIP version 1, it's a classful routing protocol. Classful, as I told, it doesn't support any subnetting. So classful routing protocols will not support subnetted networks. Okay, and this will not support FLSM and VLSM also. fixed length subnet mask and variable length subnet mask. And RIP version 1 uses global subnet mask. This is 255.255.255.255 to send its updates when it's coming to RIP version 1. Next, coming to RIP version 2. It's a classless routing protocol. So, classless routing protocol will support subnetted networks, as I told in the previous classes. And it supports FLSM and VLSM because it is a classless routing protocol. It supports FLSM and VLSM. And coming to RIP version 2 uses multicasting. Multicasting to share its updates, that is 224.0.0.9. So this is the number where it's using for to share its updates for multicasting. This is the difference between RIP version 1 and RIP version 2. So in real time, we are not using RIP because it supports only limited. It supports only 15 devices. So we have advanced compared to RIP. We have much more advanced, that is EAGRP, and much more advanced is OSPF. So RIP is a like they may ask some questions in your interviews, but mostly in your real time you're not working on RIP protocol. Okay. Okay, in RIP timer, we have something in RIP, we have timers. So we have four timers, that is update timer, and we have invalid timer, we have hold down timer, and we have flush timer. Okay, so what is this update timer? As I told, the default update timer is 30 seconds in RIP. Every 30 seconds, it keeps updating its routing info. Any whatever is happening, it keeps updating periodically in periodic basis in case of RIP, and indicates how often the router will send out a routing table updates. Is going to indicate how often the updates are sharing in this routing table. And every RIP routes will maintain these timers. Every RIP routers are going to maintain these timers. When a update happens, the router will restart the timers. When update is happening, the router is going to restart the timers. So update timer is nothing but it is doing it periodic basis, that is every 30 seconds. Next, coming to invalid timer. So coming to invalid timer, the default invalid timer is 180 seconds. Okay, it is just 180 seconds and indicates how long a route will remain in routing table. So the by default update timer is 30 seconds. It keeps updating for 30 seconds, but default invalid it is invalid timer is 180 seconds. So this is gonna indicate how long the route will remain in routing table, how long it's going to remain in routing table before it's being marked as invalid. Like if no new updates are heard about this network, if there is no new updates are heard, then it is going to consider as invalid after that 180 seconds. Okay, and the metric will change into 16 hop, means it is unreachable. I told we have total it like RIP supports only 15 devices, but if the metric will change into 16 hop, it means it is unreachable automatically once invalid timer passed. This is a 16 means it will automatically consider it is as invalid. Okay, and the route will placed into hold down time, hold down state. So once it is updating, then if it will consider after 180 seconds it's invalid, and after this it is going to place in hold down state. Again, coming to hold down timer, the default hold down timer is 180 seconds. Okay, it indicates how long RIP will suppress the route in hold down state. So the default hold down timer is 180 seconds, and this indicates how long RIP suppress the route in hold down state. And RIP will not accept any new updates. Like because it is on hold down timer, it is not gonna accept any new updates for routes in hold down state until the hold down timer expires. Okay, it's holding. When it's holding, they will not accept any. Okay, okay, okay. RIP will not accept any new updates. It's not going to accept any new updates for routes in hold down state until the hold down timer is gonna expires. Okay, this is about hold down timer. Next, last one is flush timer. So the default flush timer is T4, sorry, 240 seconds. So this indicates how long. This indicates, okay, this flush timer indicates how long a route can remain in the routing table before being flushed out if no new updates are heard about this route. So in flush timer, this is going to indicate how long a route can remain in the routing table before being flushed out if there is no new updates are heard about this routes. And coming to flush timer is running concurrently with the invalid timer. Okay, flush timer is running concurrently with the invalid timer. This invalid timer is 180 seconds. Why it is marked as invalid? Because there is no new updates or something. Same thing here. It is same as invalid timer. So the router will flush the router after 60 seconds once it is marked as invalid. So these are the four timers in RIP. So next, coming to configuration, RIP configuration. So we have RIP version 1, which is a classful routing protocol, and this supports only classful networks as I told. And step 1 is we have to enable the protocol. Protocol is RIP protocol. And step 2 is we need to advertise the known networks to the protocol. Known networks we are going to advertise. So that is version 1. Then we are going to give exit. But it's coming to version 1. So next, if you are moving to version 2, it is a classless routing protocol. This is going to support all the subnetted networks. So in step 1, first we need to enable the protocol. Then step 2, we need to enable the version. So which version it is. Next, coming to step 3, we are going to advertise the known networks to the protocol. So coming to static routing, we used to advertise the unknown networks, but coming to dynamic routing, we are advertising all the known networks. And fourth step is we are going to disable automatic summarization. So first enable protocol is router RIP, and we are enabling the version as version 2, and we are advertising the known networks, like we are going to give network and which is directly connected we are going to give, but we are not going to give any subnet mask or next hop IP address. Coming to this dynamic routing, and we are going to give no auto summary. So we are going to advertise the no networks to protocol, and we are going to disable automatic summarization using no auto summary command. Then we are going to give exit. So these are the commands for the verification. So coming to show IP route. Okay, show IP route. It is going to display the routing information and show IP route RIP. It is going to display the RIP, only specific RIP routing information. And we have show IP route network. Specific network, you can just give specific network. It is going to display the specific network information. Again, coming to show IP route connected. So it is going to show which routes are connected. And we have show IP interface brief. is going to display all the interface details to which interface it is connected. And we have show interface name. You can give particular interface name like interface jig 0/0 0/1 particular interface details it's gonna display. And we have show run pipe section rip. So you can use all these commands for the troubleshooting purpose.